Welcome everyone in our engineering virtual classroom. Now I'm going to discuss my sixth lecture on workshop and manufacturing practice. Here the subject or topic I'll discuss is machining on lathe. And last class also I have told you the cylindrical job mainly starts by the lathe machine. And I will show here a particular with a particular geometry of the job, means finally what product we want with the geometry and how it is cutting in the machine. Please follow the lecture. Here in this class we will perform a machining operation, sample machining operation. We will prepare a round headed pin by the lathe machine. The lathe machine, which is superior for cylindrical types of job, and that's why we have choose here to perform a cylindrical job. Means our workpiece, its initial condition it is cylindrical, and finally after completion of the cutting, again it is cylindrical. Three different lathe machine is available in our workshop. The two of this machine is given here. This is called all geared machine. In this machine, a number of speed of these spindle or chuck can be given because a number of gear combination is available here, and the automatic feed of the tool, that also can be vary. For that, separate feed mechanism is there, and that's why the gear cutting, the thread cutting, this type of operation can be done by these machines. But here in this machine it is cheap and no variation of speed and feed, automatic feed is available here. Only for doing the cylindrical smooth surface we are using this particular lathe machine. Now let's see what is the particular job and in which machine we can do it. Our job can be done in both the machines. This is the workpiece on which we will work to obtain the desired shape, and this is the desired shape, which is name has as here a round headed pin. One types of pin, no specific application is there. To show the various well known operation in lathe machine, we have choose this type of model as per the syllabus. The dimension of the workpiece can be measured by a vernier caliper, and if we see from the side it looks like a rectangle like this with length 7 to 72 mm initially, and if no unit is mentioned here, means the unit is in mm. And if we look from this side, it looks like a circle, this circle. Here we have drawn this circle. So this is the projected view of this rectangle. The diameter of the circle is 20. Now for this again, if we take the side view, this part is a rectangle, this part is another rectangle will with lower radius, and there is a groove, and this is the final last part. So various cross section, if we look from this side, this neck part is not visible, that's why it is represented by dotted line. So these are the dimension of the job to be done. what operation we need to do to get this job from this workpiece or raw material. Firstly, it is the length 72 and the diameter is 20. But here the maximum diameter is 18. So reduce the diameter throughout the length. This diameter reduction is known as turning process. Then again further reduce the diameter. This 18 to diameter 12 throughout the length. And in this part for 5 mm length, again reduce the diameter. It is called the grooving operation or separate, because the turning tool is unable to move there, and that's a separate tool we are using. This is called the grooving, and here the grooving operation will be performed. So first is the turning operation, then this grooving operation. And now the overall length is 72 before cutting, and after that it is the summation is 70. So 2 millimeter we have to reduce from this side, and as well as to get the finishing, proper finishing of the surface, we have to reduce this length. And this can be done by a third operation called facing. Now let's see how the operation is doing there. Before going to the video presentation, let us see the procedure. The steps already I have told you the steps. Another first, not necessarily you have to maintain this sequence, but facing to, if there is a rough surface on this face, firstly you can face it by facing operation. Then go through the marking, means up to what which operation can be need to be done. Then reduce the diameter, means the turning that I have told you, and this is the grooving. Again this part is the turning, and final finishing facing. And after completion of this, we have to check the dimension, and for that two different cutting tool we are using in the tool post. This particular cutting tool is for this grooving operation, and V-shape cutting tool that is used here for the turning operation. And we'll control the speed from here, feed speed, by rotating these knobs. Now let's see the video of the working procedure. This is our lathe machine. We are not using the all gear lathe, as it is the simple cylindrical job, so we choose this particular lathe for the operation. Here it is this 3-jaw chuck. We have to set the workpiece here on this 3-jaw chuck, and the chip that will generate will be deposited here, and after completion of the operation the chip will be collected and it will be cleaned. So this is the 3-jaw, and you notice that by controlling this, all these 3-jaw can be controlled and it is properly centered. Make it tight there. The job is fitted. Now switch on the machine and it is running. So the chuck is rotating, means job is also rotating. Now this is the tool which is used for facing and turning purpose. So set the job. So come close to that. Just it will be in contact. Then will give the depth of cut. First just toss it, just it has been tossed. I'm starting with our operation by facing. This is the tool, almost approximately the angle we are rotating this tool post and making the angle of the cutting tool nearly about 40 degree, 45 degree with respect to the axis of the job, and we will go through the facing operation. As I have told you, we have to reduce 2 millimeter. It was the total length was 72, and finally we have to do it 70. So reduce it by facing operation. Facing operation means from the contact, the cutting tool, the circumference to the center. This is the circumference, and then the cutting tool will move to the center, and it will reduced. And then this cross slide will also only move, and this entire setup will move toward in cross direction, and hence the tool is moving to centers. Okay, then it's complete, and we are getting the smooth surface here. So this is the line of operation. Again, it is the another pass, because by single pass we are not reducing 2 millimeter, say 1 millimeter, and then and the next pass by 1 millimeter. So by two pass we are completing and this spacing operation. This is the on of button of the uh, uh, machine. This machine is comparatively very easy to control. Set the turning operation now. Set initially here. This point, number of division is there, and each division equals to say 0.02 millimeter. This is called the least count. This indicates that if this wheel rotates for one division, then the corresponding linear movement is 0.02 millimeter. Maybe it is along the job or in the cross direction of the job. Now if we rotate, say initially this is the setting and finally this is the setting, means 20 division is there, then 20 division means 20 into 0.02, that is equals to 0.4 mm, 0.4 millimeter displacement. It is used to give the feed in case of turning operation, to give the depth of cut in case of turning operation. After we have tasked this here, then we will give the depth of cut, then we will run the machine. It's already depth of cut is given, zero point 0.4, so 0.4 mm radius is decreasing, and move the tool along the length. Means it is the longitudinal feed in this motion of the tool. Radius is 0.4 mm, means diameter reduction is 0.8 mm. Now it is the last operation. The name of the operation is grooving, where a sudden decrement of a particular section, cross section is there. At what distance, that is given in the uh, diagram. Now for this grooving purpose, a separate tool is used. We have used the same cutting tool, this one, for facing and turning operation, but as there is a sudden change of diameter in between these two sections, that's why a separate tool, this is called the grooving tool, we are going to use. And for this operation, by the width of this tool is less than the length of grooving operation. That's why the tool has to move along this length. And at the same time, to reduce the diameter, the tool needs to move towards this axis of the job. So two simultaneous motion is required, and that's why the longitudinal freeze and the cross slide both will use to cut this operation. Let's see. This is the length of operation and this is the width of the cut. That's why it can also have here to here. And towards this axis, it has to penetrate for that is done by marking process. We are operating by two hands for these two simultaneous direction. Finally, we are having this final product with the turning and the grooving. The surface quality depends on the various parameters like feed, speed, all this. If it is very high speed and low feed, in that case we will get more smooth surface. Even mirror like finishing also can be obtained. So this is all about our this topic. The references that I have used to prepare this video lecture is given here. I have shown in this lecture particular types of operation on lathe machine, that is the cylindrical job, and apart from the cylindrical job a number of operation is possible. And in the next lecture I am going to discuss metal joining process by welding, a particular welding process, that is arc welding, that I am going to discuss. And I would like to thank for your patience and listening the lecture. And at the same time, I'll request you, please make comments if you have any doubt and some clarification is required. Thank you.